This is a video about the gas-based power plants. So what we have discussed so far is about the conventional sources of energy, different kinds of power plants, the non-conventional sources of energy, the power plant economics, and the steam turbines. We discussed about this uh, power plants like hydropower plant, and the thermodynamic cycle of Rankine cycle was discussed in the last chapter. So again, gas based and also we discussed about the diesel power plants. So talking about the power plants and moving further from the thermodynamic cycle is that there is a the steam generation generator or the steam engine or even the combustion chamber in gas based power plant is a mechanical device, or we can call it as device, which would increase the gas or the fluid at a low temperature and a low pressure to a high temperature and a high pressure. And this fluid, when it will be thrown on the turbine blades using nozzles usually, and when it will when it will be expanded in the turbine blades, it will cause the rotation of the turbine. And when it will cause the rotation of the turbine, there will be it will be coupled to something known as a alternator or a synchronous generator, and this will cause a generation of electricity. Usually the rotation will happen at a speed known as a synchronous speed. And if you see the simple diagram of a open cycle gas turbine, so the gas turbine are the machine or the gas based power plants usually have efficiency of 20 to 30%. This is a very low efficiency considered to the hydropower plant, which will be having efficiency more than 90%. So again, steam based power plants usually have efficiency of 38 to 48 percentage. So the usually the loss happens in the process of conversion of the chemical energy to the heat energy. So it is not possible to use all of this energy or to convert all of the chemical energy to the mechanical energy. Some part of the energy will be always wasted in the process. And the some of the important parts are a compressor, the combustion chamber, and the turbine. So the purpose of the compressor is to increase the pressure of the air which is being supplied to the combustion chamber. So the combustion chamber, there will be fuel will be usually hydrocarbon, or it can be petroleum based like a diesel, petrol, etc. So whenever the combustion will happen, the flue gases or the gases at a high temperature and high pressure will be generated, and these gases will be transferred, and it will be transferred to the turbine blades, and where it will be made to hit at the turbine blades at a high pressure, at a high temperature, and it will cause expansion of the gases on the blades, and the expansion will cause the rotation. So in the open cycle gas turbine or the gas power plant, what will be there is that the gas which is entering the combustion chamber will be new always. It will be the gas from the atmosphere which will be taken in, and the gas which will be leaving will be exhaust gas which will be leaved back to the atmosphere. So there will be chimney and etc. construction possible. So again, if you see the closed gas based power plant, so what will happen is that the same gas will be rotating inside, so there is no entry of new gas. Once you have the gases, the gas will be working on the turbine, and again it will be cooled down and it will be fed back to the compressor, and again that gas will be used for heating purpose. So one of the advantage of the closed construction is that closed gas based power plant is that it is possible to have a smaller and compact construction of the whole unit. Again, it is possible to have these kind of power plants as it is a portable power plants. It can be transferred to other locations to provide backup power in case there is a power failure. Also, it can be used in case of the peak load where there is an extra demand to be met. In such cases, these kind of power plants can be operated quickly. One of the reasons is that to operate a diesel based power plant or a petroleum based power plant and gas based power plant in the as a peak load is that these will be usually run for a period of 4 to 5 hours in a day, and the operating costs associated with these kind of power plants are usually high. So it is more economical if you are using them to supply the peak load or as a backup power option for your factory or for your residential area, where you can use it as a backup generator in case of power failure, etc. In such cases, though the fuel cost will be high, it will be economical considering the purpose for which it is being used. So again, the fuels could be high octane gases, heavy diesel oils, etc. can be some of the fuels. So again, this is a construction of the closed cycle power plant. So again, there is a construction compressor. So this will be supplying the air at high pressure. Again, the gas at a high temperature and pressure will be leaving the combustion chamber, and this will be expanding on the turbine blades, and there's a cooler, and the cooler will be water cooled, or there could be condenser and cooling tower, etc. possible. And most of the turbines which are used for the gas based power plant are axial flow turbines. So this was a simple lecture about the overview and the construction of the gas based power plant, etc. And this is a series of lecture about the power plant engineering and the power system engineering. The full link for the playlist for the videos you can find in the description. Also, the videos related to the electrical engineering different topics can be found in the description, the link to the playlist. If you like this video, please do subscribe. Also, if you have any suggestion for any of the videos related to engineering or related to electrical engineering which you want to make in the series, you can comment that in the description. That's all.